Section 1. Introduction to Trail Grooming. The purpose of this video is to provide snowmobiling agencies, associations, and clubs with guidelines that are a resource for grooming recreational snowmobile trails to help improve the quality of trails and the effectiveness of grooming efforts and expenditures. Training snowmobile trail groomer operators on the proper operation and maintenance of grooming equipment, proper trail grooming objectives, principles and practices, and trail grooming safety issues. Increasing community awareness of snowmobile trail grooming requirements and practices, including the need for the public to allow proper setup time on freshly groomed trails and safe operating procedures for snowmobilers when encountering groomers on the trail. The overall objective of snowmobile trail grooming is to provide smooth trails that are suitable for all levels of rider experience. This can mean many things. Establishing a trail base at the beginning of the season, having to re-establish a trail after heavy snowfall and/or winds have obliterated it, or having to work a heavily mogul trail back into a smooth surface. Throughout the season, the key to successful trail grooming is for the groomer to build a solid base of snow pavement for snowmobiles and grooming equipment to operate on. The groomed trail base will be packed solid from the ground up, while the snow off to the side of the trail will generally be soft and maybe several feet deep. This means that both snowmobiles and the grooming equipment can become stuck should they venture off the packed trail base in deep snow areas. As a groomed operator, the trail is your friend. Know where it is and stay on it. It is important to understand the minimum level of grooming frequency or grooming standard that is established for trails in an area. It is always driven by the available budget, available workers, and equipment, and results in priorities needing to be set. As a result, it is likely that all trails in an area may not receive the same minimum level of weekly grooming repetitions. Some states categorize their trails as level 1, 2, or 3. New Hampshire has local club, primary, and corridor trails. Primary and corridor trails are typically wider trails, groomed several times a week, and carry more snowmobile traffic than club trails. When categories like these are used, it is important that grooming equipment operators follow through with commitments and snowmobilers understand the expectations. Every grooming operator should be able to demonstrate an understanding of the basics of snowmobile trail grooming, know the grooming equipment they are operating, and identify its key controls, components, and features. Start, operate, and control the groomer. Demonstrate good operator safety procedures. Demonstrate proper equipment operation techniques and procedures. Perform proper equipment inspection and maintenance. Perform proper record keeping. Know the local area and local procedures. Trail grooming objective: grooming snow, physical properties, and metamorphism. Regional and seasonal differences in snow quality will influence the ideal method for trail preparation. In general, the goal of the trail grooming is to reduce the snow particle size and produce some different particle sizes in order to maximize the number of bonding, the overall quality, or physical properties of the snow prior to and post-grooming are of some importance. The most important indicator properties of the snow are particle size, temperature, wetness, and the final snow hardness or strength. Snow density, or the mass per unit volume of the snow, is not necessarily a good indicator property of snow strength, since very wet, unbonded, melt-free snow can be of very high density but have very low strength. The 4 steps of trail grooming. The primary purpose of grooming is to remove moguls and compact the trail base. This is not simply a matter of knocking off part of one mound and pushing the displaced snow into the adjacent dip. A cut and fill grooming operation produces an uneven snow density that can result in a poor riding experience. Even though the trail may initially look smooth, the trail will most likely quickly revert back to moguls as the soft snow is pounded out of the filled dips by passing snowmobiles. 4 basic operations are required to produce a well-groomed trail that is durable. They include Step 1, removal of moguls. Step 2, processing the snow. Step 3, compression of the processed snow. And Step 4, trail setup. In most cases, grooming with a multi-blade drag will produce results superior to grooming with a single blade drag or a tiller, since a multi-blade drag generally does a good job of accomplishing all 4 steps, while a single blade drag or tiller accomplishes some steps better than others. For this reason, a multi-blade drag has been chosen to demonstrate the 4 grooming steps. Step 1. Removal of moguls. Ideally, moguls should be completely cut away from the snow that forms the trail base. Beware that if the top is simply cut off a mound and dropped into a depression of the adjacent dip, it can result in the same mogul returning in no time at all. By completely removing the mound, all the way down to the bottom of the adjacent dip, the profile of the mogul is eliminated from the trail. However, also beware not to cut into a layer of snow that forms the compressed trail base below the bottom of a mogul's dip. The mogul should be removed, but not the solid trail base below it, so care must be given to cutting no deeper than the bottom of the dips that form the moguls. This requires that the cutting depth must be continually monitored and adjusted by the groomer operator. There may be limitations to successfully removing the entire mogul. If there is bare ground showing at the bottom of the dips of the moguls, do not attempt to cut the whole mound off, since it could damage the equipment and result in destroying whatever hardened trail base there is. If using a single blade drag and the moguls are deep, it is likely that snow could be lost out of the sides of the drag when cutting deep enough with the blade to successfully remove the entire mogul. In this situation, it is better to save the snow on the trail base rather than spilling it out the side, where it may be lost for the purposes of grooming. If using a multi-blade drag, it will not cut any deeper than the depth that the planer blades extend below the bottom of the side rails of the drag when it is fully lowered. If the trail bed is soft, the side rails may cut into the trail bed, but if the trail bed is hard, the rails will typically ride on top and limit the cutting depth. In all cases, the goal should be to remove all or as much of the mogul as is reasonably possible to produce a trail that will stand up better to snowmobiling traffic. Oftentimes, multiple grooming passes may be required to achieve this. Multi-blade drags accomplish mogul removal by using multiple sets of planer blades angled to cut into the moguls. The preset cutting depth of the planer blades are typically stepped slightly lower from the front of the drag, which results in the deepest cutting depth when the drag is fully lowered so it rides flat on the side rails. Again, if the depth of the moguls exceeds the depth of the drag blades, multiple passes may be required to accomplish complete mogul removal. When deep, fresh snowfall covers moguls on the trail, it may not always be possible or practical to completely remove the moguls. In such a case, it is critical that extra attention is given to steps 2, 3, and 4 later in the video. A new hardened trail base must be created to cover the profile of old moguls below the new layer of snow. Step 2. Processing the snow. At any given time, there may be several types of snow on a snowmobile trail: hard packed snow, soft snow, wet snow, dry snow, ice, freshly fallen snow, wind-blown snow that is typically small granules, and some of the hardest snow, or snow that has been pounded by snowmobiles and worked so hard by groomers that there is little consistency left in it. It is critical that all types of snow be processed to achieve proper trail compression and setup. Snow processing is accomplished by the establishment of a rolling or churning action in front of the blades as they move forward at a correct and constant speed. In many drag designs, the multiple blades are angled so the snow moves from side to side, further mixing and homogenizing it. While the snow is being mixed, it is also de-aerated, meaning that airspace between snow particles is removed to make it denser. When using a single blade drag, it is critical that this rolling action is achieved since there is only one blade, one shot at properly processing the snow. This churning, tumbling, or milling action removes air from the snow and at the same time breaks up the compacted snow, from which moguls are formed into smaller granules of various sizes. It also breaks away points from individual snowflakes so they can be compressed more tightly. The mechanical action of the churning and tumbling has another important purpose in that it can sometimes introduce moisture into the snow mix due to friction. This friction causes the temperature of the snow to actually rise, be it a very small fraction of a degree, which can create a small amount of moisture in the processed snow. This is especially valuable when snow is very dry. Introducing this moisture into the processed snow is also very important to the success of Step 4, achieving good trail setup. It is critical that the rolling or churning action is achieved. If snow is allowed to ball up or plow along in front of the blades without this rolling action, the snow is not being properly processed. This can be caused by the groomer traveling too fast, grooming conditions being too warm or too wet, or improper drag blade height. The height of the drag's blade is critical to proper processing of the snow. If the trail is fairly smooth or only slightly moguled, only a minimum of snow will need to be processed, since it isn't desirable to disturb any more of the trail base than what is needed to remove the moguls. In such cases, there may only be a need to have snow churning in the rear sets of blades on a multi-blade or only a partial blade full on a single blade. If the trail is heavily moguled or there is lots of new snow, more blades on the multi or greater depth on the single blade will likely be required. Remember, process only as much as is needed to remove the moguls, but no more. Proper ground speed is also critical to proper processing of the snow. Too slow in the proper churning, rolling, and mixing to produce the friction that is needed to improve trail setup is not achieved. Too fast and several factors work against effective grooming, particularly with multi-blade drags. First, too high of a ground speed results in the angle blade spraying snow out of the sides of the drag, where it is lost and wasted for the purposes of grooming. Snow is precious to the grooming operation, and most areas can ill afford to deliberately throw it off the trail. Second, the rolling and churning action is partially dependent upon forces of gravity, so proper time must be allowed for the snow to roll, churn, and fall out. Third, going too fast can sometimes, in effect, overprocess the snow and prematurely wear it out. Processing snow can be similar to using a blender. Low to mid speeds can achieve good mixing and blending, but setting the speed too high can actually start to change the consistency and even liquefy what's being processed. The same can be true with grooming, in that the quality of the snow can actually be adversely affected by going too fast. And fourth, regardless of using a single blade, multi-blade, or tiller to groom, too high of a ground speed results in a side-to-side rocking that produces a rough versus smooth finish trail. Irrespective of the type of groomer, the best quality trails in terms of both smoothness and durability result from grooming at speeds between 5 to 10 miles per hour. After the processed snow passes through the last set of blades or the tiller, there should be an even blend of loose particles ready for compression. Step 3. Compression of the processed snow. The moist, loose snow created by processing step-up must be compressed into an even covering of uniform density with a smooth surface. This process further de-aerates the snow and provides for a denser trail surface. On a multi-blade drag, the front of the pan is angled, so loose snow that is contained by the side rails is captured and pulled under the spreader pan, where it is then compressed by the weight of the moving drag. Since single-blade drags typically do not have side rails, the snow must pass under the single blade of the unit and then be compressed by the drag's pan. If too much snow is carried in the single blade, it spills out the sides. This difference means that the multi-blade typically increases the finished snow depth base of the trail with each pass, while the single blade increases trail depth only when there is an accumulation of new snow on the trail. Step 4. Trail Setup. Setup is simply allowing the snow that has been disturbed by cutting, processing, and compressing the proper time required to refreeze. Generally, the longer the setup time that is allowed, the more durable the trail will be, and the longer the newly created smooth surface will last. The last step in the grooming operation allows the moisture that was created during the processing step to refreeze. This binds the individual granules of tightly packed snow firmly together, creating a hard surface that will withstand passing traffic much better. The length of time needed for a trail to set up correctly can vary from 2 to 6 or even more than 10 hours, depending upon the temperature and moisture content of the snow. Trail setup can be similar to freezing a tray of ice cubes. After a short time, there'll be a crust, but the cube isn't entirely solid, and it generally takes a few hours for it to fully become firm. A snowmobile trail is no different. Therefore, it is vital that the trail remain as undisturbed as possible during the setup period for firmer, better quality trails that will stand up longer to snowmobiling traffic. Ideally, a snowmobile trail would be closed during setup time, but that isn't practical. Consequently, the best time to groom is generally at night, when traffic levels are typically lower and air temperatures are generally colder. For the best setup, it is strongly recommended that grooming occur at night after snowmobile traffic subsides. This also provides for the safer operation of both groomers and snowmobiles, since it is easier to see oncoming lights and beacons. Most importantly, night grooming provides for more effective grooming since there is typically more time for the trail pavement to freeze solid before traffic resumes, maximizing the effectiveness of the area's grooming dollars. It is recommended that daytime grooming be done in areas only if there is little or no daytime snowmobile use on the trail being groomed. Other exceptions would include special circumstances, such as when daylight would aid operator visibility, for initial early season trail setup and establishment, or for trail reestablishment after big storms, extremely heavy snowfalls, and/or significant wind events. Section 2. Grooming Equipment. The purpose of this section is to give a general overview regarding the various types of equipment that are available for trail grooming in order to help operators understand the general characteristics of the equipment they are operating. For a more detailed understanding of specific trail grooming equipment, operators should consult with equipment manufacturers and refer to the manufacturer's Equipment Operator's Manual. As touched upon in Chapter 1, the grooming tractor is generally a heavy-duty 2- or 4-tracked vehicle whose primary purpose is to provide the power to pull a grooming drag, power a tiller, or carry a compactor bar across the top of the snow. Some areas also use farm tractors with or without track conversions to pull a grooming drag. Other areas use a wide track, utility snowmobile, or a tracked ATV to pull a miniature grooming drag. The groomer should be of sufficient size and power to handle the grooming implement that's going to be used to groom the trails without being heavier or wider than what is really needed for the area to help keep operating costs down. The actual work of grooming the snow on the trail bed is generally performed by the drag that is towed behind the groomer. There are numerous trail grooming drags commercially available, including but not limited to TSI Mogul Master, Trail Master, Arrowhead, AFMI Trailmaker, Maxi, Surtrack, Snowplane, Snowboss, Trailplane, Spooner Machine, Easy Pull, and Lacrosse. Additionally, there are numerous homemade grooming drags in use across the snow belt. Each has advantages and disadvantages. From the discussion on grooming steps in Section 1, it should be clear that a grooming drag plays a very key role in successful trail grooming. In fact, the drag arguably is the most important piece of the grooming equation and typically has a greater impact upon proper trail grooming than the groomer used to pull the grooming drag. Most modern drags are technically advanced devices referred to as multi-blade drags, as opposed to an older generation of single-blade pipe drags. There is still a place for the old pipe drags on early soft snow, as well as compactor rollers to compact new snow or pack to the outer edge of the trail. Regardless of the manufacturer or individual details of design, multi-blade drags have become the current standard for most grooming organizations that use drags. If an area doesn't have one, purchasing one could be the single best investment the grooming program can make. Because of the superiority of the multi-blade design, this section will go into great detail to explain its features and operation, since full-featured, heavy-duty multi-blade drags must be properly operated to be effective. As the name suggests, multi-blade drags use at least 2 or often 3 or more sets of cutting blades to fully remove moguls and perform the all-important snow processing operation. The width of the drag is dictated largely by the width of the trails that will be groomed and the width of the groomer or groomer that will be pulling the drag. If the vehicle's track width is 8 feet, then the drag should generally also be at least 8 feet wide. The width will also be dictated by the narrowest clearing width on the overall trail system to be groomed. If there is a bridge that is only 8 feet 6 inches wide, then the groomer and drag must be narrower than this, even if the rest of the trail system is 10 feet wide. We do not recommend a drag of more than 6 inches wider than the groomer, or it could easily hook trees, bridge rails, rocks, etc. Most trails require a doubling or are groomed to a dead end and then back over the same track. This facilitates overlapping 1/3 to 1/2 the left side of the drag width in the center of the trail to give 2 passes over the middle that normally is the roughest. The length of the drag is important in that the longer the unit is, the less tendency there is for it to follow the contour of the trail, since it bridges from high spot to high spot, filling depressions as it goes, which leaves a smoother trail. However, there are constraints to the overall length of a drag in terms of the ability to negotiate tight turns or windy trails through the woods. Typical length is 12 to 18 feet. Generally, the heavier the drag is, the better it is able to cut through moguls and compress loose snow after it has been processed by the cutting blades. However, the demands on the groomer increase substantially. As width, length, or weight of the drag increases, that may make it too heavy or too awkward for the groomer to pull efficiently. Be certain the groomer isn't overburdened with too large of a drag. The following are brief descriptions of the typical features of a multi-blade drag. The frame supplies a rigid foundation, onto which the various components are attached and should not bend or twist significantly when stressed by the drag working. If the frame becomes bent or twisted, it can result in the drag cutting or compacting unevenly. Therefore, it is important that the drag's frame be regularly checked and maintained. The outside edges of the frame form the skid surfaces upon which the drag slides and are referred to as the side rails. Side rails are important in that they keep the snow that is being processed contained within the inside of the drag frame and not spilling out. Spring tripping blades. As the blades cut off moguls, they may hit rocks, stumps, or other fixed objects buried in the snow. While not all drags have spring tripping blades, it is highly desirable that each of the individual cutting blades is spring-loaded so they can trip out of the way if they hit a buried object. This can help prevent damage to the drag groomer and the operator. It is desirable for the cutting blades to be slightly beveled so they can cut into the mogul versus being mounted straight up and down, where the blade would simply skim over the top of moguls. They are typically mounted in a stepped manner, where the front row is 5/8 of an inch below the side rail, and the rear row is up to 3/4 of an inch below the side rail. This provides more cutting depth as the frame is lowered. Also note that blades are typically mounted in an angled manner so that they can transfer snow from the outside of the trail to the center of the trail, where wear is usually the greatest from snowmobile traffic. The tongue on many drags is hinged so it can move up and down at the drag frame, but not from side to side. The up and down movement is controlled by a hydraulic cylinder operated from the groomer's cab, allowing for simultaneous continuous control of blade cutting depth on multi-blade drags. The tongue may attach to the groomer with either a pintle hitch or a fifth wheel type of hitch. Other drags, particularly those used behind farm groomers, are steered hydraulically by means of a rigid hitch. The compactor pan should provide for full-width smoothing that leaves an evenly finished trail surface free of holes or divots. The front of the pan is angled forward to catch and spread the processed snow evenly across and under the pan. The rear of the pan has a high-radius lip that aids in ramping the drag up onto the snow when backing up in soft snow without the aid of the wheels. The bottom of the compactor pan on a multi-blade drag is typically flat steel with wear bars or runners positioned at the two outer edges. 2 to 3 additional replaceable wear bars are often evenly spaced across the center of the underside to help protect the pan surface. Some pans may also be surfaced with either a plastic comb material or sheets of corrugated steel. However, flat steel or corrugated steel is better than plastic for a pan's bottom since they produce friction, which is so important to the trail setup. Replaceable hardened steel skegs or runners are normally mounted on the bottom of the compactor pan. These skegs reduce side hill slippage of the drag and also help prevent premature wear of the compactor pan. They are especially important to drag steer groomer configurations, whereby the drag acts as the steering rudder for the entire grooming unit. This example shows the telltale marks from Packer pan skegs. Vibrating pans are a relatively new feature on multi-blade drags. They utilize a flow control valve and return system to hydraulically vibrate the rear pan in an effort to increase compression and aid trail setup. The hydraulic vibrator is mounted so as to isolate the vibration downward into the trail surface and away from the drag itself. They are most commonly used with agricultural groomers since their hydraulic systems will more readily accommodate the operational needs of vibrating pans. The wheel assembly is a set of wheels mounted either at the rear of the drag or within the frame assembly that can be raised and lowered by hydraulic controls from the groomer's cab. During normal grooming operations, the wheels are raised so they are out of the way. When crossing roads or railroad tracks, the wheels are lowered so the drag is picked up off the ground. The wheels are also helpful when backing up the drag. Some drags use rear drum rollers rather than wheels. The drum is typically operated like wheels, in that it can be hydraulically raised and lowered. It can also be used to aid trail compression and compaction. Quick release features. The drag may encounter immovable objects such as stumps or rocks that could damage it, the groomer, or the operator. Consequently, a shear bolt or pin is generally used in the hitch that will break away before major damage. Quick release couplings in the hydraulic hoses can also help ensure that the hydraulic system is not torn out in the event the shear pin releases the drag from the groomer. Many earlier drag designs, which are still used in some areas or under certain conditions, particularly early season, or to cut edge-of-trail berms aggressively, incorporated a single, full-width cutting blade with the idea that it would carry snow and allow it to drop into depressions. Some designs also incorporated a rolling drum in front of the rear compaction pan. This type of drag can work well in areas with frequent deep snowfall, where grooming requires more continuous work to build new base because of frequent snowfall or early season building base. However, in areas with heavy moguls, the single blade drag can be less effective due to its limitations for fully cutting and processing moguls. Other than number and configuration of blades, the components of a single blade drag are very similar to that of a multi-blade drag. The operation is different than a multi-blade in that the height of the cutting blade is regulated by a hydraulic cylinder versus by the hitch. Additionally, since this type of drag does not have side rails to keep snow contained within the drag, snow can be easily wasted out the sides if the operator attempts to cut and carry too much snow with a single cutting blade. A compactor bar, also commonly referred to as a packer bar, is a very simple, lightweight implement, short in length and attached to the rear of a groomer, which can be hydraulically lifted completely off the snow to allow the tracked vehicle to easily back up and/or turn quickly in tight spaces. Some models also have hydraulic down pressure to help increase compaction. Rollers are large, round drums pulled behind the unit to pack snow very effectively in deep new snow and early season to build a base. They both can be used to significantly reduce the time, effort, and cost of opening a snowmobile trail at the beginning of a grooming season by compacting snow on the trail to set up a firm base for future grooming with a drag. In swampy areas, it can facilitate compaction that helps drive the frost into the ground and helps freeze the swampy ground faster. The use of a packer bar or roller generally saves wear and tear on a drag during early season trail setup and also provides for increased traction on the next trip. Either implement can also be used after exceptionally heavy snowfalls during the season or in areas of extreme drifting when a drag can be too much for the groomer to handle effectively. Some areas track pack a trail route with just the groomer and no drag after a heavy snowfall or at the beginning of a season when there is deep snow and no established trail route. This practice is understandable because the effect of the tracks can help stabilize the snowpack, but the use of a compactor bar or roller, particularly when there is deep snow, can greatly increase the effectiveness and efficiency. Groomers. The term grooming groomer or groomer is used to refer to a broad range of tracked vehicles or semi-tracked vehicles used to pull grooming drags, rollers, and compactor bars. The term groomer is used generically to identify the purpose of the vehicle, which is to pull, power, or move a trail grooming implement, pack, and level snow. Groomer components. The tracks on a groomer provide flotation that help the vehicle stay on or near the surface of the snow while providing sufficient traction to pull a heavy grooming drag. Historically, most groomer tracks were cleated with a steel or aluminum bar. Such a track requires that the vehicle be operated in deep snow to avoid damage to the tracks. Oftentimes, ice picks or grousers are added to these tracks to help prevent side slippage and spin out on hills. Many contemporary groomers, large and small, are equipped with all-rubber tracks, which allows the vehicles to be operated in all types of terrain without damage to the tracks. Some rubber tracks have a straight bar-type pattern, while others have a Z-type pattern to help prevent side slippage and increase traction. Machines equipped with rubber tracks can drive on paved roads, bridges, dirt roads, and deep powder snow, which makes them much more versatile. While they initially may cost more, they typically have a smoother ride, which provides additional operator comfort, less operator fatigue, and less maintenance costs and vehicle damage caused by vibration and broken cleats. Cleat tracks typically provide more traction in deep snow or climbing in mountain terrain. Steering is accomplished on some two-track models by individual braking of the tracks, similar to how a bulldozer is turned. On other two-track models, steering is accomplished by individually controlling track speed using a hydrostatic drive system. Most four-track models articulate, so one set of tracks turn inward while the other set turns outward. Farm groomer conversions typically utilize the drag as a steering rudder. The groomer's cab provides a protected environment for the operator. Many also have additional seating for a passenger that is useful for training or for a relief operator on long runs. Most groomers have complex instruments for operating the groomer, as well as hydraulic controls that operate the grooming drag, front blade, and other attachments. It is important that operators familiarize themselves with all controls to ensure safe and effective operation of the equipment. Vehicles that have upfront cab styles provide better forward visibility for the operator, particularly when using a front-mounted blade. Many modern groomers are equipped with a front blade, which is a useful accessory to knock down snowbanks or drifts and to fill in creek crossings or large depressions in the trail bed with snow. A blade is also useful to keep road crossings and driveways clear of snow deposited by grooming or sleds, so as to not create hazards for motorists or obstructions to adjacent landowners' property. A front blade is also very useful for leveling drifts, cutting side hills, or sloping corner berms, but require a very competent operator to use effectively. One common misconception about the front blade on groomers is that they can be used as a bulldozer. This is not true, and if used as such, can result in major breakdowns and repairs. Front blades on groomers are typically not as strong as the blade on a bulldozer, so they should never be used as such for pushing large rocks, stumps, or trees. Some groomers have a rear cargo deck to carry utility loads such as tools, chainsaws, spare fuel, trail signs, etc. The operator must be aware that overloading the cargo area on the groomer can impact the vehicle's weight, flotation, and center of gravity, so caution should always be used to not improperly load the vehicle. Important characteristics of trail groomers. There are several characteristics that are important to understanding the capabilities and the proper operation of groomers. These characteristics include ground pressure. A vehicle that is designed to work in snow must stay on or near the surface rather than sink in and plow through the snow. This is accomplished by spreading the weight of the vehicle out over the tracks, much as a snowshoer's weight is distributed by the snowshoes. The technical measure of the vehicle's ability to distribute weight is called ground pressure. Ground pressure is calculated by dividing the overall weight of the vehicle by the total area of the track which remains in constant contact with the snow, and is most often expressed in pounds per square inch PSI or kilogram force per square inch centimeter KSC. Typical ground pressure for moderate light to heavy groomers range from 0.8 psi or 0.056 KSC to 1.2 psi or 0.084 KSC. It is very important that ground pressure not exceed these limits. If ground pressure is too high, the vehicle will sink into snow rather than stay on top. If ground pressure is too low, the unit may not have sufficient traction to pull a drag up hills or through deep heavy snow. Overall weight. Within reasonable limits, the overall weight of the groomer can be compensated for by matching it with the appropriate track area. However, overall weight is a factor in terms of existing bridge loading limits and crossing frozen bodies of water. Because grooming vehicles are typically very heavy, it is recommended that they never be operated on frozen bodies of water without special planning, testing, and training, since doing so could lead to equipment damage, serious personal injury, or death. Engine horsepower and torque. Regardless of whether a diesel or gasoline engine is installed in a particular unit, the key measurements of its capability are its horsepower and torque. Always use the same measurements when comparing horsepower, since there are gross, net, and power takeoff (PTO) measurements. Gross brake horsepower is a good basic unit for comparing the relative power of engines. Engine torque is an often overlooked rating that is very important for all groomers. Torque relates to the ability of the groomer to get a heavy drag moving. The high static loads of modern multi-blade drags require a high degree of engine torque to get a drag moving from a dead stop. Center of gravity. A vehicle's center of gravity is a point around which its weight is evenly balanced. A vehicle's center of gravity is significant any time it must operate on a non-level surface, such as when climbing or descending steep grades or when side-hilling. In terms of stability, the lower to the ground the unit's center of gravity is, the more stable it will be on non-level surfaces. Operators should keep this factor in mind to avoid getting into unsafe conditions. Tractive effort is defined as the amount of torque that can be applied to a track before the track loses traction and spins without moving the vehicle forward. When a track breaks traction, it is actually shearing the snow through the force that the crosslinks are placing on it. Fresh, unpacked snow shears much more readily than hard-packed snow. When a vehicle breaks traction, spins out, and gets stuck, it happens because the force required to shear the snow is less than the force required to pull the load. The load is made up of both the drag and the groomer. Snowmobiles and ATVs for grooming. Some areas either use a wide-track utility model snowmobile or a tracked ATV to groom their snowmobile trails. In these conditions, the snowmobile or ATV is typically used to pull a small grooming drag, usually only about 4 feet wide, when there are limitations with trail widths that prevent a larger groomer from grooming the trails. A snowmobile or ATV may also be used because of funding limitations in the area that preclude the capital expenditures required for larger equipment. While there are limitations as to what can be successfully groomed with a snowmobile or ATV, these units can serve a valuable purpose. One key to success is frequent grooming repetitions to compensate for the cutting and compression limitations that small drags typically have. The grooming drag is typically controlled by an electric hydraulic switch operated from the front of the snowmobile or ATV. This allows the operator to make drag adjustments just the same as if the operator were in a full-size groomer cab. Manual adjust or dead-pin drags are still common in some areas, but not as efficient. Because the operator is out in the elements, it is important that extra safety precautions are taken for operator safety and that the operator has adequate dry clothing along. It is also important that a tow rope and shovel are carried on the snowmobile or ATV, since it is easy to get these units stuck. A spare drive belt and spark plugs for the snowmobile should also be carried, since pulling the grooming load can be hard on the snowmobile's clutch, engine, and drive belt. These operators must wear helmets for personal safety. All other grooming and safety principles apply, just on a smaller scale. Section 3. Managing grooming operations, equipment, and safety. Grooming operations are typically the largest part of an entity's budget in terms of the capital cost to purchase the equipment, the ongoing operational costs of grooming, and the costs associated with repair and maintenance. While there is no perfect way to manage grooming operations, this section provides basic guidelines for the management of trail grooming equipment and operations. What equipment to purchase, who will operate it, how it will be scheduled, where it will be stored, and how it will be maintained are all critically important decisions that must be made to properly manage grooming equipment. While some of these decisions are far removed from the grooming equipment operator, a basic understanding of the big picture helps facilitate a better, more effective grooming operation. The Trails Administrator. Good quality grooming doesn't just happen by chance and will not be assured simply because new fancy or expensive equipment has been acquired for the grooming program. Successful grooming programs require a great deal of planning and experience. Good equipment isn't a substitute for poor operators or poor timing. Regardless of the size of a grooming operation, it is recommended that there be a qualified manager in charge of the day-to-day grooming operation, who understands equipment operation and maintenance, trail grooming principles and practices, and snow mechanics. The ability to work with a diverse group of volunteers or employees while balancing leadership and authority is essential. The title of Trail Master or Trails Administrator is important in New Hampshire since it clearly defines the role of the individual filling the position. Trail or project clearly indicates the focus of the job. Master or Administrator defines the role as coordinating and directing all aspects of the overall grooming program. Particularly with volunteer, club, or town grooming operations, the person that missed that meeting or the new kid in town simply taking this job because no one else will, that's a recipe for disaster and should be avoided. Establishing grooming priorities. Snowmobilers would like to see every trail groomed tabletop smooth every day of the week. However, grooming resources in terms of available equipment and existing budget are usually limited, so choices have to be made as to what the grooming priorities are. Grooming schedules should be developed that divide trail systems into manageable sections based upon time, what the budget will allow, and volunteer or labor resources available. Once priorities that consider traffic patterns have been determined for each trail section, a weekly schedule can be created by assigning grooming equipment and operators. Keep in mind that while schedules are great for planning how to use resources, weather and changes in traffic patterns can upset the best laid plans. The Trail Master or Trails Administrator must stay engaged and flexible to ensure grooming is directed toward the highest priorities if conditions change. A number of factors should be considered when determining priorities and schedules. Where is the base of operations for the grooming program located? Is it central to the trail system, or is it located at one end of it? How many miles of trail must be groomed? What is the normal use pattern on the trail system? Is the snowmobile traffic normally heavy only on weekends, or is traffic heavy every day of the week? Is there typically heavy night riding, or are snowmobilers generally off the trail by dark? How early in the morning do riders normally get on the trail? Are there lodges, motels, restaurants, or other businesses located on the trail that contribute large numbers of riders on a daily or regular basis? Are there attractions on the trail system that draw more traffic than other parts of the trail system? Are there trailheads or parking areas that regularly draw more use than others on the trail system? How many groomers are available for the trail system? If 2 or more are available in the area, can they be staged in different directions, or must they operate all from the same base? How many miles of trail can each unit effectively groom each shift when considering the setup time required to avoid heavy snowmobile traffic, average grooming speed, and normal weather patterns and temperatures? How many weeks will there be enough snow and traffic to justify the expensive grooming operations in the area? Should the trails receive more grooming during one period of time than others? What is the cost to groom a mile of trail one time, fuel, maintenance, repairs, equipment depreciation, and labor as applicable? How many dollars are available to fund these costs for the season? Will all labor be paid labor, or will there be volunteer labor to supplement operating costs? Is there volunteer labor? How many hours per week will be dependably and consistently available? How many total miles of grooming effort will this fund each week? The answers to these questions all contribute to establishing priorities and setting grooming schedules that will be as effective as possible to address grooming needs. If areas have traffic levels that are generally low with little night riding and low weekday traffic, there is more flexibility as to when grooming efforts can be effective, and few grooming repetitions per week will generally be required to have good trails. If traffic levels are high every day of the week, areas must look closely at scheduling factors to be as effective as possible with grooming expenditures. It is likely that 5 or even 7 repetitions per week may be needed to have good trails, and multiple groomers staged at multiple locations may be required, since 40 to 60 miles is the maximum a single large unit can effectively groom per night without getting into times, traffic, temperature that may not be productive for grooming. While some high-traffic areas choose to groom midday, especially on weekends, to keep moguls from getting too deep, such efforts should be discouraged. Operator selection and training. For many of the same reasons that a skilled trail master or project director needs to coordinate a grooming program, skilled groomer operators need to be carefully selected and trained. Grooming equipment operators should be selected based on their ability to operate equipment and then be thoroughly instructed and tested on the operating features of the grooming equipment, grooming principles and procedures, maintenance schedules, and safe operating procedures. Operators should be knowledgeable of grooming practices and should have a fairly high degree of mechanical aptitude and common sense, since on-the-trail repairs and adjustments and decisions are inevitable even with the best equipment. An operator training checklist should be used to help deliver effective and consistent operator training. Training topics should be customized by the trail master or project director to cover local issues, but should also cover general items such as grooming practices, vehicle characteristics, and vehicle operation. Following this process can help ensure that operator training is thorough and complete. The core components checklist is a good guide. Ensuring the safety of equipment operators must be the first priority of the grooming program. While the specific circumstances of every area's operation are different, there are a number of common safety practices that should be followed universally. The following is a list of common operator safety considerations. Always wear seatbelts. Operators and passengers should wear seatbelts at all times, since dangerous sudden stops caused by the grooming equipment hitting or hooking fixed objects, such as rocks and stumps, that can easily launch the operator or passenger headfirst into the roof, windshield, or dashboard. Be visible to snowmobilers. Ensure that the vehicle is highly visible in the daytime as well as at night by using reflective surfaces on the equipment and by always operating with cab marker lights, front and rear headlights, and an amber beacon turned on at all times. Be prepared for trouble. Grooming equipment will malfunction, break, and get stuck. Contemplate all potential problems and provide procedures, tools, spare parts, and supplies to deal with them. Provide first aid kits and training for operators. Remember that they may also encounter members of the public who need help. A GPS unit is valuable to provide guidance during whiteouts and to provide rescue coordinates. Operators should be prepared to winter survival techniques into effect in the event they become disabled in a remote area and must stay overnight. Essential tools that should always be carried include axe, chainsaw, and safety clothing, jack, snow shovel, chain tow strap, rope, duct tape, and flashlight. A list of standard safety emergency equipment should be carried in the groomer. Here's a list of items to consider with each groomer. First aid kit, spare batteries, fire extinguisher, foil blanket, weatherproof matches, chains short and long, flares, a pry bar, spare clothing, tools, paper towels, a snow scraper, plate for jackhand, a cleaner, high lift jack, tree strap, engine oil, extra fuel, stakes, sledgehammer, orange spray paint, flagging, butane propane, a torch heater, trail signs, large orange cone, and high-energy food. It is strongly recommended that every groomer or drag carry a minimum of 4 14-inch reflective high-visibility traffic cones. Use them to identify potential hazards temporarily, such as a disabled groomer, washout, bridgeout, or a tree in the trail. Never string wire cable or chain across the trail that is not secured. Avoid grooming across ice. Some state or provincial trail programs do not allow groomed trails to cross lakes or other major hard water crossings. If it is necessary to groom across ice, procedures must be established to ensure that ice quality is adequate in thickness and quality before crossing. Some manufacturers install escape hatches in their units to facilitate emergency operator exit from the cab should the unit go through the ice. Seatbelts should be unhooked only while crossing the ice. Stay in communication and work the plan. Modern FM radios and cellular or satellite telephones make it easier for operators to stay in frequent contact with their home base. Always file a trip plan before leaving on a grooming run. Agree upon a regular schedule of contact between the groomer, operator, and home base and the procedure that will be followed if contact is lost. Ensure that a plan is in place should contact be overdue or an actual emergency is reported, and then stick to the plan. Carry extra signs for replacement. A supply of extra trail signs, stakes, and fasteners should be carried on the groomer to replace missing signs or stakes, since the groomer operator is often the most frequent person knowledgeable with where these signs should be along the trail. Replacing the missing signs, particularly safety and regulatory signs, helps ensure that the route will be safe for snowmobilers as well as for the groomer the next time it must pass through the area. The groomer operator should not be the primary sign maintainer. Routine preventive maintenance. The importance of an effective preventive maintenance program for safety should not be underestimated. Well-maintained equipment is far less likely to injure an operator or to strand an operator in a difficult or dangerous situation. Failure to perform preventive maintenance procedures should be treated as a safety violation rather than an operational oversight. Thoroughly check the groomer over prior to departure on a grooming run. Check the fuel and fluid levels. Check for cracked or broken parts. Check the tracks. Check the hydraulic lines. Check the flashlight and be sure the tool and emergency kits are together. Be sure to have adequate clothing along in case the heater or groomer quit and safety cones are on drag. Do not leave unless everything checks out okay and is in place. Always use caution when stopping or parking on the trail so the groomer does not become a hazard for approaching snowmobilers. There are essentially two types of stops, planned and unplanned. A planned stop is one made by a groomer operator when there is full control over when and where to stop. Always use good judgment in where stops are made on the trail, and be certain the groomer is well off the side of the main traveled portion of the trail, if at all possible, when the machine is parked. Plan ahead and pull over in an area that minimizes risk to traffic on the trail. Pull completely off the trail on a straightaway, at an intersection turnout, or in a parking lot whenever possible to prevent having to stop on the trail and potentially create a hazard. It is good to develop areas on the trail system where planned stops and/or turnarounds can be made safely, and then keep these areas packed throughout the season. An unplanned full stop is one made when there isn't control over the location of the stop. This can include meeting snowmobiles on a narrow trail, having snowmobilers stop the groomer to ask for information, encountering blowdowns, washouts, or other situations requiring trail maintenance, mechanical failure of the groomer, encountering a disabled snowmobile, or encountering an accident on the trail. Operators must use their best judgment to quickly size up the location of the unplanned stop. Is the site safe or unsafe to stop with a groomer? Can the trail be secured? If you believe the location has good visibility, that the expected time to get underway again will not be lengthy, and it is safe to stop at the site, stop briefly to correct the problem, handle the situation, or give information, but do it as quickly as possible and then get underway again. If you believe the site is unsafe due to the location and/or visibility, look for other options such as moving, erecting warnings, pulling off at known turnouts, and if possible, using extreme caution while proceeding to a safer location to stop. Snowmobiles approaching the groomer from the front. When snowmobiles approach the groomer from the front on a narrow trail, move the groomer to the right side of the trail as quickly as possible and stop. After checking to see that no traffic is coming from the opposite direction, signal to the snowmobilers to proceed past the groomer. Informational stop by snowmobilers. Tell the snowmobilers that it is not a safe location to stop. Request that they follow the groomer down the trail to a safer location where you'll stop and answer their questions. Repairs to the trail or removing blowdowns. If you anticipate the time needed to stop to remove debris or deadfall, or to repair the trail will be relatively short, make sure all warning lights remain on, and quickly make all the necessary corrections to the trail, then get underway again. If the stop is anticipated to take a longer period of time, consider placing warning devices on the trail to warn snowmobiles of the groomer's presence. If the groomer becomes disabled or stuck on the trail and cannot be moved, take action quickly by placing warning devices in the front and rear of the groomer to warn approaching snowmobiles of the hazard. If the groomer needs to be left on the trail for an extended period of time, place additional warning signs or devices to mark the groomer's presence. Assistance to disabled snowmobile. If you anticipate there will be a need to be in the location for an extended period of time, park the groomer as far right on the trail as safely possible and place warning devices in front and back of the groomer. If communications are available, call for assistance for the snowmobilers and get underway again as quickly as possible. Groomers aren't tow trucks. Crash-related stop. If you come upon the site of any crash, presume that it is most likely an unsafe site. Do not proceed until the site is made safe. First, park the groomer as far right on the trail as is safely possible and place warning devices on the trail to warn snowmobilers of this hazard. After securing the site, assess the situation to determine if there are any injuries and, if so, the type of injuries and the number of people injured. If the accident is because a snowmobile collided with a groomer, do not move the equipment. Just secure the scene, assess the needs, call for help. As you assess the situation at the accident scene, determine if current resources at the site are sufficient to handle the emergency. If the answer is yes, offer any assistance you can give and stay at the site until the trail has been cleared. If the answer is no, the current resources at the site are not sufficient to handle the emergency, take control and A, call local dispatch or 911 if phone or radio service is available. If not, send someone for help. B, state the problem or situation clearly. C, give the number of injured, if any. D, give the location, trail number, or trail name. E, if known, state the best way for rescue to arrive. F, stay calm and do not talk too much. G, don't move the injured, but protect all victims at the scene and keep the injured warm. H, if there are bystanders, ask them to either secure the trail or direct traffic until other help arrives. I, update emergency personnel upon their arrival. J, document. After the scene has been turned over to emergency personnel, write down everything that you observed and that transpired while you were at the accident scene. Common operator guidelines and policies. For the benefit of the operator and/or grooming program, many areas have formal guidelines or policies related to operator safety, practices, or behavior that include no alcohol or drugs, a zero-tolerance policy regarding the use of alcohol or drugs when on duty. Some areas specify a period of time prior to a grooming shift where alcohol cannot be consumed to prevent operators from showing up for their shift under the influence of or impaired by alcohol or drugs. Some areas go as far as to not allow groomer operators to run their shift if they have a hangover, since the grooming managers believe this also constitutes an impaired and therefore unsafe situation. Zero tolerance means there is no second chance. Operators are terminated for their first infraction, since the safety risks and the liability associated with impaired groomer operators can be extremely significant. No smoking. Many areas prohibit smoking while in grooming equipment in their shop and in maintenance areas. Certainly, smoking must be prohibited around all refueling areas. Smoking bans are due to operator health and safety. Smoking in the cab of groomers can also decrease the unit's resale value. Passengers in groomer. While some areas routinely groom with 2 people in the groomer, a driver and an assistant, other areas prohibit the operator from carrying passengers not involved with the grooming operation. The most important aspect of whether or not to allow passengers is a safety issue. First, is the operator competent enough to not be distracted by a passenger? Second, the trail master or trails administrator should know beforehand that there is a passenger, so in the event of an emergency, rescuers know how many people they need to retrieve. Communications. Communications are so important to the success of any grooming program that many areas have established formal communication policies and procedures. All are based on the need to communicate the condition of equipment to other operators and the trail master. They must communicate the condition of the trails that they've been over to relief operators and the trail master if they even slightly suspect the information is pertinent to the overall grooming program or someone's safety. When in doubt, operators must feel safe to ask, because there is no dumb question. Grooming programs should invest in good communications equipment, whether cell phones, satellite phones, or two-way radios, to help ensure successful and effective communications within the program. Remove bumps, holes, and debris prior to snowfall. Trail preparation prior to freeze-up and snowfall can be the single most important item to help provide safe grooming and a smooth and stable winter trail. Early season trail preparation. The first snowfalls that are processed on the trail often create the base for the remainder of the winter. An early solid, smooth base of snow will help keep the trail smoother throughout the rest of the winter. Early winter snowfalls can contain more free water and can compact well. Thick layers of newly fallen snow typically do not compact well. Section 4. Operating grooming equipment. As noted in Chapter 2, there are a broad range of types and styles of groomers, drags, and implements. Each has its own operating procedures and requirements, so it is important to become familiar with the peculiarities of all equipment by reading the Equipment Operating Manual. The following tips provide valuable guidance for operators that should be followed in addition to equipment-specific guidelines and instructions provided by the manufacturer of the equipment. General Operating Guidelines. The amount of snow depth required to begin grooming operations will vary by area and is affected by the type of terrain and by the type of snow. Remember that it requires a lot more snow to safely and effectively operate a groomer than it does to operate a snowmobile. And it can be a good thing to let snowmobiles run on the snow first before you start grooming operations, because it starts the de-aeration and compression process. Generally, at least 8 to 12 inches of wet snow on smooth terrain like a road is enough to begin grooming operations. However, if the snow is drier or if the terrain is rough or uneven, at least 12 to 18 inches of snow may be required to safely begin effective grooming operations. Generally, when using a drag, grooming operations should be suspended when the temperature is below minus 25 degrees Fahrenheit or above plus 40 degrees Fahrenheit, because it can cause snow to stick in or on the implements enough of the time to make grooming a smooth trail impossible. It is essential to stay on the trail base at all times with grooming equipment. If it is necessary to re-groom a section of trail, find a place to turn around where there is ample turning room and it is known that the snow base will support the equipment. If in doubt, get out and walk to check the snow depth. If a turnaround is attempted in an area where the snow is deep and loose, there is a risk of becoming severely stuck. If possible, use areas where turnarounds have been made before. These turnouts also make good locations to take breaks, stretch, and do an equipment check. Building trail base versus maintaining trail base. Anytime there is new snow to work with, either through new snowfall, blown-in snow, or snow that is pulled in from the trail's edges, grooming will build the trail's base depth. If new snow is not available, grooming will simply maintain the trail base, which is a much less desirable situation. Remember that a drag's blades must always have snow in them to accomplish either trail building or maintenance, but snow spilling over the rail or shooting over them is not grooming. In most areas, the ideal groomed trail width will be 1.5 to 2 groomer widths, typically 9 to 16 feet. However, landowner permits, local conditions, and equipment widths will dictate what this means on any given trail segment. The clearing width in some wooded areas may only accommodate a single drag width, while other trails are located on improved roadways. Always groom on the right side of the trail with the direction of snowmobile traffic. Take the right side of the trail and stay there. Then reverse the grooming direction the next time in order to widen the trail, rather than grooming against snowmobile traffic on the left side of the trail. If grooming in tandem, the lead machine should be on the right side of the trail with at least one grooming machine length between the groomers, and all warning lights need to be in operation. Constantly watch in the rearview mirrors to monitor the finished product on the trail behind the groomer. When using a drag, this is particularly important, since the drag blades can quickly empty out and go from totally full to totally empty within a few seconds or over less than 15 feet of trail. This can mean spending as much as 75% of the time monitoring more closely what is happening behind the groomer versus in front of it. Leave the vehicle periodically and walk back to check the finished trail surface behind the groomer, especially at night. Operators must know their trail to be able to anticipate the need to carry extra snow, either with the front plow or in the drag, as they approach areas that are bare or may be in need of additional snow to establish a good trail base. Such areas can include ditches, bare hillsides, windswept or sunny areas, areas of rough or rocky terrain, the crown of hills or approaches, the bottom of curves, etc. If the operator doesn't anticipate and plan ahead, it'll be too late to improve the trail defect once they're at it. So when going through a dip, swale, or ditch that the drag spans or bridges, anticipate the need to lower the drag blades before getting there to gather snow. Conversely, when approaching a particularly drifted or deep snow area, a steep hillside, a switchback, or a road crossing, anticipate the need to make upward adjustments to the blade depths, front and/or drag, in advance of the location to avoid getting in trouble by spinning out or getting stuck. Pay special attention to curb berms and try to work down the high outside edges. Be careful not to completely straddle these berms, or the groomer may get high-centered or pull straight into woods. A drag will not usually stay on the side of a sharp curved snow berm. It is often best to push snow into the bottom of the curve or cut the berm with a front blade or plow and then work the new snow in the bottom of the curve with the drag. Take the time necessary to get a smooth trail by regulating the speed of the groomer and cutting the depth of the implement according to trail conditions and grooming needs. If there is a particularly rough area and a place to turn around, groom the trail a second time. Whenever it is necessary to back up on the trail, be sure to remove the pile of snow or tire ruts that backing up can often create, since these piles can become safety hazards for snowmobilers, particularly once they freeze. This requires either backing the pan off the edge of the trail, re-grooming that section of trail, or removing the snow pile with a shovel. Think visibility. Groomers should be operated with their warning beacon, strobe, and lights on at all times to increase their visibility to snowmobilers approaching on the trail. A slow-moving vehicle SMV sign should be displayed at the rear of all units, since a groomer is nearly stationary when compared to a fast-moving snowmobile. The rear of the drag could be a great spot to mount the cones used to block trails in a breakdown. Don't leave holes on the trail. Never leave holes caused by being stuck, drag malfunction, spring water holes, bridge, deck spaces, or operator error in the middle of the trail, since holes can be a hazard and cause injury to unsuspecting snowmobilers. Cover ice. Cover icy spots with snow if possible. Sometimes icy spots can be scored with a scarifier blade to aid in traction and steering, and also to try to help process it into the snowpack. Groom bridges. Often operators fail or can't groom across bridges. This can lead to extremely rough and unsafe trail conditions before, across, and after bridges. Start by simply panning across the bridge if possible at the beginning of the season to prevent damaging the bridge's deck. Use the groomer to bring snow onto the bridge if needed and eventually build the trail base to a depth that can be regularly groomed. If the bridge is ungroomable, warning signs are essential. Tips for effective grooming with a drag. Remove air from hydraulics and compensate for leaks. After hooking the drag to the groomer, activate the hydraulic controls in the cab to raise and lower the drag a few times to remove any air that may have entered the hydraulic hoses and cylinders. Inspect all connections for leaks. If there is even a slight leak, promptly fix it to prevent spilling hydraulic fluid into the snowpack and potentially harming the environment. Until the leak is fixed, remember that the loss of pressure can cause components to settle, which may require compensation by continually adjusting, raising, the drag component controlled by the leaking hydraulic. Carefully inspect the hydraulic hoses or electrical wire for binding and interference as the groomer unit is turned. Check for clearance between the outside of the tracks and the outside front of the drag when the groomer unit is fully turned. Pay attention. Operating trail grooming equipment is a demanding job that requires the operator's undivided attention at all times. While it is important to be watching the trail ahead to observe changing conditions, it is as important to watch what the grooming drag behind is doing. Don't simply drop the drag and forget it. Instead, it requires that the operator constantly respond and adjust to ever-changing trail and snow conditions. Keep the rearview mirrors on the groomer clean to constantly monitor how the snow is processing in the drag blades, as well as the finished surface behind the groomer. Get out of the groomer to occasionally walk across the groomed surface. Check trail consistency by scuffing across the finished product with a boot. If the operator sinks, recheck groomer settings to ensure good processing and compression of the snow. The effective grooming speed when using a drag is typically 5 to 10 miles per hour and is primarily governed by the way the snow is being processed by the drag. Too slow and a rolling action in front of the blade will not be adequately established. Too fast and the drag will bounce, leaving a poorly groomed trail, or may spray snow outside of the drag, wasting it. Excess speed can prevent the blades from properly cutting off the mogul and also not give snow the time it needs to fall out into a dip or a hole. Slow down and take the time necessary to get a good finished product that will stand up better to traffic. Grooming too fast is a much more detrimental factor than most operators realize and can be a huge waste of grooming resources. The trail master can monitor records to compare hours of time to miles of trail covered. Groom at night or when traffic is low. Daytime grooming early in the season while building a base or when air temperatures are very cold can be effective, but always try to groom when traffic volumes are at their lowest, which is typically at night, especially from mid-season on. This helps allow adequate time for the trails to set up properly and can also enhance grooming and snowmobiling safety. On heavily traveled trails, this could be a window of time as narrow as 1 a.m. to 6 a.m. on weekdays. Grooming at night will generally produce the best quality trail, since temperatures are typically colder, which can help the snow flow better and set up harder. However, the greatest single key to effective grooming is low traffic, so if the traffic is heavy, consider an alternate time to groom. The middle of the trail corridor is the common travel lane no matter how wide the trail may be. Snowmobiles most often operate toward the center of the groomed corridor, even though New Hampshire requires operating to the right. Use the front blade to direct snow in from the trail's outer edge or operate the drag on the outer edge of the trail first. The outside 2 to 3 feet of trail will often be softer and thicker than the middle of the trail due to the compaction that snowmobile traffic contributes in the middle of the trail. Therefore, generally groom from the outside in. Remove debris from the trail. Stop to remove significant rocks, logs, limbs, or other debris that is laying on or in the trail surface. Debris can not only be a hazard, but can also attract heat, which can have a thawing effect on the surrounding snow trail surface. Watch the temperature. The best temperature for grooming with a drag is generally in the +5 to +25 degrees Fahrenheit range. Generally, wet snow grooms best at night and dry snow best during the day if the traffic level is low. Oftentimes, early evening has the best temperatures for effective grooming. Don't dump snow on road crossings, driveways, or railroad tracks. Use care to avoid dragging or dumping snow on roads, driveways, or railroad tracks when crossing them with grooming equipment. Frozen piles of snow deposited on roads can be hazardous to motorists and cause ill will toward snowmobiling. Likewise, piles of snow deposited in driveways can strain relationships with adjacent landowners by making access to their property difficult. Always cross roads, driveways, and railroad tracks with extreme care and use caution for oncoming vehicles. Wheels on a drag should always be down when crossing sideways. If a pile of snow is left on the crossing, it may require the operator to stop and clear snow with a shovel, but they should be cautious of oncoming traffic. Don't set the drag blades too low on smooth trails. When grooming a trail with little fresh snow cover and only minimal moguling, care should be taken to not have the drag adjusted too low because it would unnecessarily process the hard-packed trail base. Cut only as deep as the bottom of the dip of the moguls. If the trail is relatively smooth, only cutters skim with the rear set of blades. Following this method can help increase the depth of the hard-packed trail base. Moguls under a deep new snowfall cannot usually be completely removed. Process the fresh snow and compact it so a smooth finish is established as the new base on top of the moguls. 2 passes may be required to achieve sufficient processing and compression when there is extremely deep new snowfall. Processing wet heavy snow is more difficult and requires more operator finesse since it has more surface tension and will not flow as well as cold dry snow. To groom in wet conditions, adjust the drag somewhat higher than if in below freezing conditions and pick up the speed of the groomer slightly if possible. Monitor the snow to ensure it flows freely. If the snow begins to collect in the drag, raise it high enough to clear the snow and lower it again, but make sure not to deposit a hazardous pile of snow in the trail when adjusting a drag. Continually monitor the drag blades, particularly when grooming trails that are relatively smooth and only lightly moguled. Operators must continually adjust the drag's cutting height. This need is different for multi-blade versus single-blade drags. The weight of the drag causes natural settling, which forces the cutting blades deeper as the frame and side rails settle. This requires that the operator must pay attention to monitor the height and readjust the drag upward as needed. It takes even less than a quick short bump to adjust the cutting height of a multi-blade drag. Essentially, all that is needed is to barely crack the hydraulic spool open, so it just barely squeals to have all the adjustment that'll be needed. Since the cutting depth of the blades are preset and step down from the front to rear of many drags, it requires lowering or raising the side rails only a fraction of an inch to substantially change the cutting depth of a drag. Additionally, since the side rails keep snow contained within the drag versus allowing it to spill out the sides, it is good to keep a significant supply of snow in front of the rear spreader pan because it helps to continually build increased trail base and will not create humps like a single blade will. Spilling snow equals carrying too much, particularly with single-blade drags when the snow that has been built up in front of the drag blade isn't rolling or churning or is spilling out the sides. The drag is carrying too much snow and is not working effectively. In most cases, a very slight tap of the control lever is all it takes to make a significant change in the amount of trail base the drag is cutting and will correct this situation. Hills can create another special challenge for groomer operators. There is likely to be a lack of snow at the crest top of the hill and an abundance of snow at the bottom. Oftentimes, the hillside may be either icy or even bare from snowmobiles spinning their tracks while climbing it. It may also be bare due to southern exposure to the sun. As much as anywhere, hills are an area where the operator must anticipate and plan ahead. Also, always keep to the right so the groomer is not a hazard. The drag may need to be raised as the groomer begins climbing the hill. Anticipate this ahead of time and adjust the drag's cutting height upward to lighten the load. If there is a safe, firm place to turn around, it can be desirable to groom a double pass on a particularly rough moguled area or hill, since this means the trail section will essentially receive 3 or 4 grooming repetitions during the double pass. Each pass cuts deeper into the base. Proper use of the front blade. When using a drag, the front blade of the groomer is best used to level drifts or to direct new snow into the trail from the edge. Snow worked by the front blade is then processed, compressed, and leveled out by the drag. Operators are cautioned to not overgroom by continually raising and lowering the front blade, which can lead to accentuating dips and rolling trail surfaces. Rather, trail leveling is best accomplished by the planar effect of a drag pulled behind the groomer. Be extremely careful to watch for rocks and tree stumps when working with the front blade. Hitting these hazards can put a great deal of stress on the steering mechanisms of some units. If the vehicle's blade or tracks hit something, let go of the steering wheel momentarily. This can reduce stress on critical parts by allowing some give in the steering system. Seatbelts are a must when front blading. While operating the groomer at grooming speed when using a drag, it is recommended to run with the bottom of the front blade set about 4 inches above the bottom of the tracks, not at ground level. This can allow it to be used for daylighting out finger or pillow drifts, while at the same time keeping it a safe distance above the trail bed and away from rocks, stumps, and other hazards. Watch behind the front blade to monitor the blade height in relation to track location and distance above the bottom of the tracks. If there is a need to use the front blade for berms or large moguls or for building trail across a drifted side slope, slow down and operate with caution. Use it, don't abuse it. 10 common operator abuses. The following are 10 common operator abuses of track snow grooming vehicles that can lead to premature equipment wear and equipment failure. Number 1, failure to perform proper warm-up. Neglecting warm-up procedures can impair control responses and cut down the life of the engine and transmission. Start the vehicle and check the steering, hydraulics, brakes, tracks, frame, attachments, etc. while it's warming up for at least 5 or 10 minutes. Number 2, failure to perform walk-around inspection. There is no replacement for an operator's daily startup inspection. The operator must be very familiar with the machine. With daily inspections, the operator has the opportunity to check for loose fittings, bolts, oil leaks, and other problems that can easily be corrected and help prevent a major problem from developing. Have a checklist for each unit. Also, stop each hour during operation and walk around the vehicle for a general visual inspection. Number 3, operating when repairs are needed. If a vehicle is operated with known problems, even minor ones, it unnecessarily risks the vehicle's integrity and the operator's safety. Number 4, operation without proper training. Untrained operators, or even experienced equipment operators who are unfamiliar with the vehicle, may overload the equipment, which can cause stress and damage the vehicle. An important part of every operator's training should be to read and understand the operator's manual before operating the equipment. Operators must always be attentive to odd sounds in the vehicle's response to controls. Number 5, misapplication of equipment to job. All too often, tracked vehicles are used for purposes they were not designed for. A grooming vehicle is not a bulldozer and should not be used as one. Knowing and respecting the limits of the vehicle's capabilities is important to protecting the life and usefulness of the groomer as well as the safety of the operator. Number 6, going too fast. Tracked vehicles are designed to pull heavy loads at relatively low speeds. Operation at a high speed over rough terrain can damage the tracks, drivetrain, or the drag, and can also cause excessive vibration that can harm the groomer's frame and components. Additionally, working in too high of a gear overworks and overheats the transmission. It also generally produces a poorly groomed trail. Operators who chronically groom too fast should be replaced, since they put equipment at risk and produce poor quality trails that don't stand up well to traffic. Faster is not better. Number 7, unauthorized modifications. Some operators believe that modifications to their equipment, like resetting hydraulic pressures or recalibrating the fuel pump for more horsepower, are smart moves. In reality, unauthorized modifications like these will often stress the vehicle beyond its limits. This can result in warranties being voided if a failure occurs or shorten the normal life cycle of the vehicle. Always check with the manufacturer before making any modifications to grooming equipment. Number 8, high temperature shutdown. Not allowing the engine temperature to stabilize before shutdown can damage turbochargers and cause premature engine wear. Always allow the engine to idle for 5 or 10 minutes before shutdown. This also provides an excellent time to perform a walk-around shutdown inspection, as well as a time to warm up the operator's vehicle for the drive home. Number 9, unfamiliarity with the trail. Operators who are unfamiliar with the trail can run into sudden hidden dangers such as rocks, trees, wet areas, and steep grades that can pose a threat to themselves and the vehicle. Operators who help construct the trail or who perform summer maintenance on the trail are a valuable asset since they know what the area looks like without snow cover. They're also the best people to have set the outer edges of the groom trail at the beginning of the season. Know the trail and stay on it. Groom with a plan and stick with the plan. Operators should follow the trail signs and never follow snowmobile tracks through open areas unless they're absolutely certain that is exactly where the trail is located. Snowmobilers often shortcut bends in the trail, and they can get the groomer into extreme trouble if it follows them off trail. Number 10, using attachments improperly. Even if the front blade can remove a large drift in one pass, make several passes and do it in smaller, less stressful cuts. Saw limbs into several small pieces before pushing them off the trail with the front blade. Use it, but don't abuse it. Section 5. Maintaining grooming equipment. The place for grooming equipment is out on the trails working, not sitting in a service shop waiting for parts or broken down on the trail with a failed component that was not properly maintained. There are enough things that can go wrong through normal grooming operations without aggravating the problems with a lack of due care. The key to ensuring that downtime and emergency repairs are kept to an absolute minimum and that the equipment remains safe to operate is establishing a comprehensive preventative maintenance program. Regardless of the type of maintenance being performed, there are 4 elements to the work that need to be addressed. 1. Inspection. A great deal can be learned about the condition of a vehicle by carefully looking, listening, smelling, and feeling. While general overall surveillance is important, the areas where failures commonly occur should be identified and the inspection criteria and methods detailed. A good operator does not necessarily have to be a good mechanic, but they do need to be observant and aware of their machine's sounds and appearances. Number 2, lubrication. Ensuring that lubricating fluids are fresh and full is extremely important for tracked vehicles. As well as lubricating, installing fresh lubricants will displace water and dirt in places it shouldn't be. Number 3, adjustment. Tracked vehicles have a number of adjustments that can compensate for wear and changes in alignment. Ensuring that mechanical adjustments are made properly is the best way to prevent failures in the field that can have serious consequences for the operator or the machine. Number 4, repair. Any part or system found to be damaged, worn out, or otherwise not doing its job must be promptly repaired by a qualified individual. There are a number of types of maintenance performed at different times for different purposes. A good overall maintenance program should include the following: first-time operation of a new unit inspection, pre-season inspection and maintenance, pre-operation inspection and maintenance daily, post-operation inspection and maintenance daily, routine shop inspection and maintenance, and off-season storage procedures. Each type of maintenance has a different purpose, so procedures should be developed for each one based upon the type of equipment. Since there are such a wide variety of groomers, drags, and attachments currently available, it is impossible to provide generic preventive maintenance procedures that fit all situations. Therefore, general guidelines as to what each type of maintenance procedure should address include: first-time operation of a new unit. It is important to both the condition of the vehicle and the safety of the operator to proceed slowly when operating a new vehicle or a new used vehicle for the first time. While the owner's manual should have detailed procedures, the following basic procedures should be followed prior to operating any vehicle for the first time. Visual inspection of entire vehicle inside and outside. Check fuel and oil levels and fill as necessary. Familiarization with all controls and functions, including owner's manual recommendations. With engine running, verify that all gauges are operating and within specified limits. Proceed very slowly, getting the feel of the vehicle and its characteristics. After the first 10 hours, or as specified in the manual, check for loose bolts, nuts, fittings, etc. Pre-season inspection and maintenance. If the off-season recommendations below have been followed, readying the vehicle at the start of a new season should be relatively easy. Refer to maintenance records and be sure that all required work was performed. Check all fluid levels and look for signs of leaks. Install and/or adjust tracks. Inspect all welded joints and stress areas for cracks. Inspect bearings, joints, and all moving parts. Pre-grooming operation inspection and maintenance. Before starting operations each day, the operator should be required to perform a pre-operation inspection. A set program should be developed for each piece of equipment based upon the manufacturer's recommendations. Post-grooming operation inspection and maintenance. As discussed earlier, many tracked vehicles should not simply be turned off at the end of a work session, or engine damage can occur. Develop a routine for shutting down the vehicle at the end of the run based upon the manufacturer's recommendations. This shut-off cool-down period is also an excellent time to walk around the equipment to perform a visual inspection, as well as to refuel. Oftentimes, it's a good idea to remove excess snow and ice that may have accumulated on the equipment during the grooming run. Routine shop inspection and maintenance. In addition to the ongoing operational maintenance described in the 2 previous sections, most tracked vehicles require regular shop inspection and maintenance. A regular program should be developed for each machine, and operators should be instructed as to when shop maintenance is required. A maintenance log can make this easier to track and remember. Off-season storage procedures. Most tracked vehicles spend a significant part of the year sitting completely idle. Taking the time to properly store them simply makes sense in terms of protecting a major investment. While an off-season maintenance program unique to each vehicle should be developed based upon the manufacturer's recommendations, the following guidelines should be followed universally. Clean and service the battery and battery compartment. Change the oil, transmission fluid, hydraulic fluids, and filters. Lube all fittings to displace water and spent grease. Check for wear points, track belts, and related components, wheel wear, cracks in carrier and frame, hydraulic assemblies, etc. Check engine compartment for belt wear, tension and alignment, throttle linkages and springs, broken or worn wiring, etc. Clean interior and exterior. Park in a garage if possible. If exposed to weather, remove or cover tracks to prevent ultraviolet UV light damage to the rubber. If stored with tracks on, release tension. All engines, gas and diesel, should be started monthly and operated for at least 15 minutes to keep valve stems coated and to put moving parts in a different position. General groomer maintenance tips. If at all possible, completely thaw out the groomer for every scheduled maintenance session, regardless of the mess and time involved. It's the only way to discover cracks and welds, missing parts like nuts and screws, etc., and will save on valuable downtime later. Always jack up each track for journal bearing lubrication, for checking track tension, and for track adjustment. When greasing track journals, a very thorough greasing is required. It's easy to undergrease, but nearly impossible to overgrease them. Aluminum or steel track cleats are often over-tightened when fastened to track belts, which can lead to a premature belt failure. A torque wrench should always be used for this task, since manufacturers' guidelines typically stipulate tightening the nuts. Always refuel the groomer at the end of a grooming run. This ensures the unit is ready to go the next time it is needed or in the event of an emergency. It also helps avoid condensation buildup in the empty fuel tank, which could lead to fuel line freeze-up and/or engine problems. Prior to fueling, idle down engine, open tank, and allow a few seconds to vent gases. Section 6. Record Keeping. The importance of keeping accurate and complete records of all aspects of a grooming program cannot be overemphasized. Good records are an important management tool, promote adherence to procedures, and may help limit liability should problems occur. It is the responsibility of everyone to keep records. A good preventive maintenance program is an important safety management tool, so keeping good records is a must. A cavalier attitude by any person toward not performing good record keeping that facilitates preventive maintenance should not be tolerated. At the same time, if records are kept, they should be used. Be sure that records are used to analyze the performance of the grooming program and as a yardstick to measure improvements. Don't just file them and forget them. Corrective action form. Groomer operators are often the best eyes and ears for the trail system, given the regularity and frequency that they travel the area's trails. During grooming operations, operators may identify conditions on or directly adjacent to the trail that need correcting. A form like this provides a mechanism to report these situations, can document when they are corrected, and is important to overall trail safety and risk management. Activity log sheet. For New Hampshire, grant programs provide a form that we require operators to complete. They're brief but include date, person, odometer hour meter gauge, recording, time of day start-end, and trail traveled. Other forms are very important, including fuel used, equipment maintenance service, but those are local issues to record. Section 7. Recommendations for Groomer Operator Certification. It is recommended that groomer operators be certified to help ensure the proper operation and maintenance of snowmobile trail grooming equipment. Certification should consist of a combination of training and testing to help ensure equipment operators understand correct grooming principles, techniques, procedures, and other pertinent subject matter. Certification can also help ensure that the expenditure of grooming funds results in smooth trails that are safe and hold up to snowmobile traffic as long as possible. Who should be certified? While groomer operator certification requirements are certainly a local decision, it is recommended that all groomer operators receive a minimum level of training and certification. In some areas, groomer operator certification may be mandatory in order for the grooming area to qualify for liability insurance. In all instances, operator certification can serve as an excellent risk management tool, so it should be universally encouraged. Since experienced groomer operators can benefit from periodic training and refresher courses, it is recommended that, if an area adopts certification requirements, all operators receive the initial training and certification irrespective of their experience. While the length of time a groomer operator certification is valid, a local decision, it is recommended that they be valid for no more than 4 years if the operator continues to operate the same type of equipment. If the grooming equipment is replaced with either new models or a different type, the operator's training and certification should be updated at that time to include training and certification for any new equipment.